Okay, now let's start question number 36. In this circuit shown, all the resistance are identical. Okay, all these resistors are identical. The reading on voltmeter 1 is 8. Okay, and the reading on voltmeter 2 is 1. Okay. Okay, what are the readings on the other voltmeters? V3 and V4. Okay. So we can just say that let the resistor or the resistance of each actually resistor is equals to R, since everything is equal. So let's start from here. So V2 they say is 1 volt, and they are saying that this resistor and this resistor have the same resistance. Okay, if they have the same resistance, you remember that in one circuit, if both of them are equally, if they have equal resistance, so the voltage will be equal on both. So if V2 is over here, this is 1 ohms, this is 1 ohms, let's say, for example. So in conclusively, there are 2 ohms over here, equal. So it's 1 volt over here, so 1 volt will be here as well. Okay. So since they are in series right now, so the potential difference across the resistor just left on V2 is also 1 volt, since the resistance is the same and they are in the same branch. So the same current is going to get flowed. So the total resistance will be 2 ohms and the total voltage also will be 2 volts. So here it will be 2 volts. Okay? Total. Let me rub it. If you just include from here till here, it is 2 volt. Okay, 1 volt plus 1 volt. So we know that if two resistors are in series to each other, in parallel to each other, the voltages remain the same. So if it's 2 volts, V4 will also be 2 volts. Okay, so so my V4 is actually equals to 2 volts. So out of which this is only 2 volts. So you can just select your answer right now even, but let's see, and let's see that V3 is 3 or no. Okay, so the complete circuit may be described as the series combination of resistors. Like right now there is one resistor and this is one resistor as well, right? So if I say like this whole circuitry, if I map it like this, we can say that your V3 is actually, if you just follow this circuit path, okay, this is one path. So we can say that V3 and the same voltage will be here since the resistance is same. So V3 plus V3 and plus 2 volts should equals to 8 volts, right? It should sum up to V1. Okay. So if you just do this equation, so 2V3 plus 2V is equals to 8 volts is equals to V3 is actually equals to 6 and 3 volts. So your V3 is equals to 3 volts. So yes, option B is the correct choice. Okay. Okay. Now let's do this question. This is question number 37. Okay, question number 37 is very interesting. The diagram shows a light. Okay. The diagram shows a light dependent resistor and the thermistor forming a potential difference. Here and here it's forming a potential difference. So here, under which set of condition that will the potential difference across the thermistor have the greatest value? Illumination and temperature. Okay. This is interesting. Okay. So you know that the potential difference is potential divider is actually formed right now. Okay. For the potential difference across the thermistor, if you want this potential difference to be great, in a greater value, so the resistor or resistance of the LDR should be small, right? If you want a high voltage over here, you need to decrease your voltage over here. And how you are going to decrease your voltage over here? By decreasing the resistance. Okay. So if you are decreasing the resistance over here, so you need to increase the light. So illumination should be high illumination. Okay. Or light should be high. Okay, so that the resistance is decreased and so that the voltage across this particular thingy is decreased, and the thermistor will have a higher value. And you should also know that when the temperature is low, when the temperature is low, the resistance of the thermistor is higher. So I have to keep the temperature low and I have to keep my intensity high. So intensity of light high and my temperature low. So option number B is the correct choice. I hope you understand.